Hey there, this is Horner, and this is AP Physics C 1990, question number 3, and this one is on oscillations. You have a couple of blocks here. We have a 5 kilogram and a 3 kilogram block. The 5 kilogram block is fastened to the spring. Spring has a spring constant of about 1,000 newtons per meter, and the 3 kilogram block rests on top of it. So when the blocks are at rest, how much is the spring compressed from its original length? Can't believe how easy this is. Super simple. So let's go ahead and just solve this one. We know that F, the force of the spring, is equal to K times the stretch of the spring, or the compression. Here we have a compression, so we're going to say that change in position is equal to the force, which is the force due to gravity of the two blocks on top, over K. 5 plus 3 is going to be 8 kilograms times 9.8 meters per second squared. You could also use 10 there if you wanted to. And our spring constant is 1,000, so you end up with 0.078 or 0.08 meters. Either of those would work. 1 point for the equation, 1 point for doing the work and getting the right answer. For letter B, it says the blocks are now pushed down and released so that they oscillate. They want us to determine the frequency of the oscillation. The big thing there is it says frequency. If you decide that you want to use t is equal to 2 pi times the square root of m over k. Remember, this is the period of a spring. Don't. Make sure that you change this to frequency. So we know that if I want frequency, so if I put frequency in, that means that is 1 over the period. So that means I'm going to take 1 over everything that's here. So that'd be 1 over 2 pi. And then we would still have the square root, but we're going to flip these. And so that will be k over m. So now we can say 1 over 2 pi as square root of k, which is 1,000, over m, which is 8 kilograms. And so that should be equal to 1.8 seconds to the negative 1, or you could say 1.8 hertz. Either way you want to do it is absolutely fine. If you accidentally did this and you solved for t and you got 0.56 seconds, if you said that is 1 over t is equal to f, and then you said f is equal to 1.8 hertz or seconds to negative 1, that'd be okay. If you just had this answer, you wouldn't get the third point. So you get 1 point for having the equation, 1 point really for plugging everything in correctly, making sure that you're solving for frequency, and then 1 point for the actual answer itself. So be really careful when you do that. Next one, determine the magnitude, so magnitude, not the direction, of the maximum acceleration, so that is A max, that the blocks can attain and still remain in contact at all times. So we want the maximum acceleration. That means that your A max, in order for them to be in contact, you can't go any bigger than gravity. So that's equal to g, and that is equal to 9.8 meters per second squared. And that's really the answer. And you get 2 points for doing that. We just want to make sure that A is always going to be somewhere around there. So, I guess really that's all you really need for that one. Letter D says, how far can the spring be compressed beyond the compression in part A without causing the blocks to exceed the acceleration in our part above, which is part C. And so in order to do that, we have to think about what is that maximum acceleration. So here we're going to say that A max is equal to K times A all over M. So our A here is really our stretch, and so that is the amplitude. So A here is the amplitude, so I'll just put amplitude. So I put the parentheses there so you can see that. So that would be our amplitude, and that's why we're looking at it the way we are. Now we know that our amplitude is equal to m times A max, because we multiply both sides by M, and then we need to divide by K. So let's go ahead and solve. 8 times 9.8 all over 1,000, and check it out, we get 0.078, and that is consistent with the answer that we got in part C. Don't forget that that is in meters. For letter E, it says determine the maximum speed of the blocks if the spring is compressed a distance found in D. So here we need to think about conservation of energy again, and so we can say that the spring potential energy should be equal to the maximum potential energy due to gravity. Potential energy due to the spring. So this is the maximum kinetic energy, potential energy to the spring, max. So here we're just going to say K max is equal to 1/2 of mv squared, and that is the maximum velocity. U, which is the spring potential energy, is equal to 1/2 K times A squared, and that is at that maximum. So let's set the two equations equal to each other, and we'll get 1/2 mv squared is equal to 1/2 Ka squared, K times A squared. And remember, A stands for that compression. We can get rid of the halves, and so we are left with V squared is equal to K A squared all over M. Let's go ahead and solve this now. So V would be equal to the square root of our spring constant, which is 1,000, our 0.078, which is our amplitude or our stretch, and we're going to divide that by 8 kilograms, and so we should get V max is equal to 0.87 meters per second. There is an alternate way to do this. You could also think about the equations that we've used for when we go from our position to velocity to acceleration in terms of the derivations, if you want to do that, and then you would know that Vmax should, Vmax should be equal to 2 pi f, so 2 pi times the frequency times that amplitude. And remember, 2 pi f is really just the rotational frequency or the rotational velocity, angular velocity, and so you could have put that in there too. But nonetheless, I think doing this one is probably a little bit easier to kind of think about as you go through. So where do the points come from in this one? There are several points. There are 4. First one is for conservation of energy. The second one is for having this equation correct, for having this one correct, setting them equal to each other, and then solving for your final answer. So you didn't have to explicitly show them like this. What we did here would have been absolutely fine as long as you show that. If you don't show this, but you show this, you're okay. If you show this and you skip right to here, you're going to lose a point. So you want to be very careful and watch out for that. But other than that, that's it. That is the end of this problem.